In the hangar here is XB1, history's first independently developed supersonic jet, and it's the 1/3 scale prototype for Overture, which is our 65-seat supersonic airliner, which will be the first mainstream supersonic airliner.
Boom is revolutionizing high-speed traveling, and they are the first one to do real digital design and manufacturing of a new aircraft.
XB1 is the product of digital engineering, which means the ability to go design something in 3D on your computer, test it, optimize it through simulation, but also to be able to realize it quickly in real 3D form through 3D printing.
We use our Stratasys 3D printers to create functional prototypes in order to do fit checks or gauges while we're building the vehicle. We use them for drill blocks, as well as using the machines to print flight hardware that's actually going to fly away on the XB1 demonstrator.
So this is XB1 supersonic demonstrator. Compared to Overture, this is 70 feet long. Overture is going to be 210 feet long. So a smaller airplane, but it's got all the technology you need for mainstream supersonic flight. And our designers, using in-house 3D printers from Stratasys, were able to go see how the designs were working, iterate faster, and ultimately come up with parts that are better designed, that are more lightweight, for less time and less money that would have taken otherwise.
The way they are approaching the development cuts years from the development phase and also at the manufacturing stage.
So we have built hundreds of 3D printed drilling fixtures, jigs, other kinds of build and assembly tools to make XB1.
This drill guide is used for drilling holes in our aft fuselage. Using the Stratasys F900 on this particular drill block saved us about $3,700, and it also saved us a significant amount of time. So instead of taking weeks for us to get a CNC 5-axis machined aluminum component in-house, from a design to part in hand, it only took us a couple of days.
We deliberately keep the printers very close to the manufacturing and also very close to the engineers. So the 370 was our first one, and we put that actually upstairs with the engineers who were designing so they would understand the capabilities of the process, start to build it in their design thinking. The F900, we've used for the production parts on the airplane, and having that capability right in-house is super valuable for us.
Our FDM technology is perfect because it's versatile, and you can address many different applications that are unique for aerospace.
So if you're going to enable a lot more travel, and if you do that by making flights that are faster and more affordable and more convenient, people are going to travel more often. So you have to make not a little bit of progress in sustainability, but a lot. And from a design perspective, the ability to iterate faster through digital design and 3D printing lets us come up with designs that are fundamentally more efficient.
This is a great example of what we are calling in Stratasys mindful manufacturing. Why? Because when we are taking the 3D printing industry from prototyping to manufacturing, we have an obligation to make the manufacturing more sustainable versus the traditional system that are being used today.
Stratasys and Boom have been partners long before we started to build the first airplane, because we had a shared vision of how digital design and digital manufacturing could help us deliver more speed into the hands of passengers faster and more efficiently.